All right, this is your lesson plans for the week of April 19th through April 23rd. Okay, so open up your agenda books to April 19th. You'll notice that you guys are testing on Tuesday, Thursday, and Friday of this week. And all three of those, bless you, all three of those will be language arts tests. But
what's the math full day again? This week, what's the math full day?
Tuesday and Wednesday. Okay, let me get the schedules out for those. I've got schedules up on the board, but you guys can't see those very well. Feel free to take a picture of it out on your during your free time, passing period, whatever. But I'll show you guys your schedules starting tomorrow. So today we are doing some math ILEARN practice questions like the ones you took on your practice test, but no one went over those with you. So I'm going to go over them with you. We should finish 10 of those today. We should. You are taking the language arts computer adaptive test tomorrow from 7:30 to 9:30. Then we are going to be on a 2-hour delay schedule following that, which means you'll have 30-minute core and encore classes. What would be your period 1 class is going to be kind of a flex period. It's going to be back in your SLT doing DEAR, and we're going to be reading while some people that need the extra 30 minutes to finish up have that time. You may not need any extra time. None of you might need any extra time, and that's fine. We'll just do 30 minutes of DEAR then to kind of reset before we start our day. Yes, Dylan?
So next year with our like SLT being turned into core classes, will that be shortened as well?
I have no idea what next year's schedule is going to look like yet. It's been revised so many times that I'm not even sure. So once I find out, I can let you guys know, but I may not find out till over the summer. So it may just be you guys show up at school and they say, this is what's going to happen. So Levi.
During this 30 minutes of reading time, are we allowed to work on homework?
You won't have any.
Well, like tomorrow.
Yeah.
That's going to be up to Mrs. Yentez. You can ask her. I'm guessing the homework you'll have will be from her. Did you go homework from her today? Caleb?
How many questions are on the
I do not know.
Will it be like a lot?
I honestly don't know. I can tell you that the computer adaptive test is going to be similar to NWEA, not in the number of questions, but in the fact that when you answer one question, you get a completely different question after that. It's not related to the previous one. Okay, so that's what computer adaptive is, and that's what NWEA is. If I answer NWEA questions wrong, eventually they'll ask me 3rd grade questions to see if I know anything. And so I'm guessing you'll get a score, whatever your score is on that will be depending on how many answers you had correct, and then what level you got to by answering those correct questions. Yes? No, you'll get your score back probably like a month after you take it.
It's actual people grade, it's not computer.
Well, this part is computer, and then there's some parts. Yeah, there's some parts that anything you type has to be graded by hand. Yeah, but like multiple choice doesn't have to.
Why would anybody sign up?
Okay, let's keep going. You're going to stay in your core 1 for a 30-minute core 1 class period. Okay, so you're just stuck in that class for half the day, and then you're going to do encore 1, encore 2, lunch, and then finish the rest of your core classes in the afternoon. Normally, we wouldn't have core 2 in the afternoon, but with this extra SLT DEAR period we put in there, it got bumped. Okay, so that's what tomorrow's going to look like. That schedule's on the board. Wednesday, there is no test. However, we're still on a 2-hour delay schedule, minus the fact that Wednesday you're coming in at 8 o'clock instead of 7:30. And so they're giving anyone who needs to finish Tuesday's test an hour and a half to do that. Or if you weren't at school on Tuesday and you come back on Wednesday, they're going to give you that hour and a half to get that test taken. And if you need more time, you'll have it. If for those of you that have already finished the test, you'll have to see what Mrs. Yentez has planned for you. I'm guessing she's going to let you guys bring in some games to play, like card games or board games for that hour and a half. I know I'm letting my SLT period to do that. The ones that aren't taking the test that day, which most of you won't because you'll be here tomorrow to take the test. So Wednesday is not a test day, but because some of the school is testing, we're still following that school schedule. And then we're going to have core 1 and core 2 both in the morning because we don't need an SLT DEAR period since 99% of the people aren't testing. And then we'll have core 3, 4, and a success time. Now, this success time we could actually start the Lord of the Rings during that time. So we might actually do that. And I'll talk more in a second about the Lord of the Rings. Okay. Yes. Yeah, 50-minute success time, because we're not sending you back to SLT since you've already spent half the day in your first period class. So you guys will be with me for success time. Well, unless we decide to start the movie, in which case you might go back to SLT time just to start the movie. On Thursday is a testing day. So on Thursday, you'll be taking the ELA performance task. Now, none of the ILEARN tests are timed, but the performance task test has to be finished that school day because it's one item that they're asking you 4 or 5 questions about. And so you can't go home and like prepare anything. They're going to make you finish it before you leave school. It's plenty of time. I wouldn't worry about that. But yeah, you need to finish that. And that 2 hours should be, again, more than enough time for most of you to finish. And if it's not, there's an extra half hour of flex period while we'll be doing deer reading. And then instead of core 1, you'll be going to either the red, white, or blue room, which will change each day. Now, you guys were in the Panther blue group when you did your NCAA brackets, right? So outside of mine, Mr. Sylvester and Mrs. Yentez's rooms will be either a red, white, or blue piece of paper. During this class period, you'll be looking for the blue. It'll be with either Mr. Sylvester or myself. I'm not going to send you guys back to Mrs. Yentez since you already had her for most of the morning. Okay. You'll go to the blue group, which the blue could be either outside my door or Mr. Sylvester's door. And then you guys are going to do the Lord of the Rings activity, which will be either one of my worksheets or most likely Mrs. Yentez is going to get you started on her character development thing, where you guys get to pick a different race from the Lord of the Rings movies. You've got the elves, the dwarves, the hobbits, the orcs, that kind of stuff, the race of men. And you're going to create a character and a background and a backstory for your character as well. Caleb.
What happens if you would get quarantined during ILEARN?
Then you'd have to take it all when you come back. Okay. Yes. Max.
What if we get done with the performance task like in 30 minutes?
Then you sit there for an hour and a half.
And like you just have to sit there?
Yeah. To my knowledge, they don't even let you bring a book for that. And you have to go back to your locker to get your book when we're done testing. That's what we've done in the past. I don't know if that's what we'll do this year or not, but you have that whole time. So there's no need to rush. When it says you're at the end of the test, I'd go back and double check everything. Devin?
Did we like have IXLs to do if we're quarantined?
Why would you have IXLs?
Because instead of Lord of the Rings.
But you can still do the activity.
Uh,
Yeah. With very minimal knowledge of the movies, you could still do the activity. Okay. We're just punishing those people who didn't take their permission slips home.
What
So
if
far-
they did, but their parents didn't
Well, then
allow
we
it?
wouldn't punish them. But guess what? Guess how many people have come to me and said that that was the case?
0.
0. And we only have 4. And of the 4 students that we have, Harrison and Camden are 2 of them. Where's Harrison at? Harrison, when you're watching this, make sure you email me your permission slip. Camden is here. He just gave me his, right? Yeah, so it should be, now we have Harrison, and then I've got 2 others. All right, we're gonna be going to encores like normal, and then after lunch, we'll begin the Lord of the Rings movie. Now, it says SLT plus. You guys will be back in your SLT room with the extra members of Mrs. Bradshaw's room that were with you guys for your brackets, which I'm not sure who those 3 or 4 people were, but they'll be with you. Mrs. Bradshaw's room is not going to have a movie in it. She's going to be doing any of the makeup tests if someone arrives late to school or if someone didn't finish the performance test. So her room is going to be a workroom for anyone that maybe have missing assignments or needs to finish the ILEARN tests. Friday's schedule looks identical to Thursday's schedule. The only thing that will change is that the red, white, and blue cards will be outside a different room, but you'll still be watching the Lord of the Rings movie with Mrs. Yentez. Okay, so you'll have her in the morning and then again in the afternoon. Okay. Again, those schedules are on my board. I won't even give you next week's schedules until Friday, so you guys can see what we'll be doing. Friday will be the last language arts test. There's 3 language arts, and then there's 2 math tests. One of which you'll take on Monday next week, and one of which you'll take on Thursday next week. That's it. Yep. It's only 5 tests. Why we stretch it out over the course of 2 weeks, I'm not sure, but only 5 tests. All right. So today, tomorrow, and Wednesday, we'll be looking at practice ILEARN questions to get you ready for the math ones. I can do that. Obviously, we won't be starting the math until Monday, so I can do that with you guys in class. You'll be starting the language arts this week. So what I need you guys to do is, well, let me get my iPad connected here. Give me a second. Go to the Test Secure app on your iPad. It's the blue and white notepad looking app with a lock at the bottom right corner. Oops, I guess my screen was mirroring the whole time and I just stopped it.
Yes.
There we are. Yeah, so go ahead and open up this app. If you're at home, you don't need to open it up. Just follow along with us because it will walk you into the app and then it will end the YouTube video if you're watching at home. So you'll just have to follow along with us. You guys can open up the app and I'll show you how to get well, where you need to go. All right. When you open up the app, everyone should be taken to this screen here. Does that look like your screen?
Yep.
Okay. Now, what I'm about to show you, you guys can do on your own time. You don't just need me to help you do it. Okay. You do not need an STN number today. You don't need any session ID number to do what we're going to do, which is just look at the what they call the released items, the practice questions. Okay. So at the bottom left of your screen, that white button that says go to released items repository site, go ahead and click on that. It will turn your page green. You don't need a test login anymore, so just click sign in. And you're going to select grade 7. With our extra time, we can look at some grade 8 ones since you guys have been doing 8th grade math this year, but unfortunately you'll be taking a 7th grade ILEARN. Which is why, and so many times during the year, we've had to stop and do 7th grade stuff from the 7th grade book because I can't have you forget everything you learned from 7th grade. And that's why we did that probability unit on Tuesday and Thursday last week as well.
So wait, so what day of the week do you do math?
Monday and Thursday next week.
Wait, so we're not doing 2020, 2021?
We will, but we're not going to start with that because the practice test that you took with Mrs. Yentes used the 2018-19 questions. And some of you have already been asking about those. So we're going to look at those first. With our extra time, we can look at the 2019, 2020. Is it 2019, 2020? Okay. So the one you're going to select is the one from on the right side, second one down from the top that says grade 7 released items. MA stands for math, G7 stands for grade 7 released items. It will take you to a screen that looks like this. You're just going to click on the green select button, and then you're going to click begin test now, and it will lock you into the app until we finish.
Do we change anything?
Nope, don't need to change anything on it. I believe your first question is this one here.
Yes.
Okay, so it's a bit out of order. Let me go ahead and stand in front of the podium so they can see me now.
My first question.
Obviously.
No way.
Okay,
Said they're out.
now this is what they called a hotspot question, where each row requires one box in each column to be selected. One column, I guess I should say, to be selected from each row. So this question actually has 5 questions. You're going to select one option for row 1, for row 2, for row 3, for row 4, and row 5. So they want us to select whether those operations would give us an answer less than 0, equal to 0, or greater than 0. So what kind of numbers are less than 0? The negatives. Basically saying, are you going to get a negative answer? Are you going to get a 0 answer? Or are you going to get a positive answer? So we have 5 questions. Let's answer them. Looking at our number line, what value can we assign to A? -2, B, and C. Okay, so on our scrap paper, which you'll have given to you by Mrs. Yentes, but for right now, you'll just have to get your own scrap paper out. Thank you, Camden, for having your scrap paper out. Were you deciding whether that was good scrap paper or whether you needed that paper? Okay. Your scrap paper is out. And you can keep this scrap paper for the next 2 days. If you don't have any paper, I've got some on that top tray back there. You can grab a sheet of paper back there. Now, on the actual ILEARN mathematics test, when you do the, this is the computer adaptive questions. When you do the computer adaptive questions, there will be a non-calculator portion first and then a calculator portion. My guess is that you will not be allowed to use your own personal calculator for any of the tests, because no one's going to sit there and watch you to make sure that you're not using the calculator on the non-calculator questions. When you get to the calculator questions, just like on NWEA, there will be a calculator icon that you're able to pick to click, and it's a Desmos calculator, so it's a pretty good calculator, but it is not your own. So you'll have to get used to using it during this test. On this test, there's only 2 calculator questions. I'm sorry, 3 non-calculator questions, and the remaining 7 are calculator questions. What's going to happen, and we'll see this in just a moment, when you get to the end of the non-calculator section, it's going to say you have ended this section or this segment. If you go on, you'll not be allowed to go back. What that means is they'll let you go back and review any of those non-calculator questions, but as soon as you go on to the next question and you got a calculator, you cannot go back and change any of your answers for the non-calculator ones. Because they know some people are going to have the questions written down on their paper, and they're not going to let you just use a calculator and go back. It is. It's not their first time. Camden.
Aren't most of the calculator questions like you don't need a calculator on now?
Probably. There's some that you'll want one. You'll see here we do a couple. These are not ones that I would even expect you to use a calculator on. For A minus B, let's just do that one. A minus B means -2 minus 2, or -2 plus -2. Dylan. It would be, yeah, because it's -4. So for the first one, I want you to select the box that says less than 0, which represents the negative numbers. Exactly. For the second one, A plus B means -2 plus 2. That is equal to 0. Remember that when it's a subtraction problem, you can rewrite it by doing keep change opposite, -2 plus -2. So that's going to give us -4. I wouldn't do that here though, because it already is addition. The whole point of doing keep change opposite is to change it from subtraction to addition. We already have addition. This is just 0. And so you're going to click the box that says equal 0. Next one, B minus C is 2 minus 4, or 2 plus -4. What's 2 plus -4? -2. So we're going to select the negative box again. C minus A is 4 minus -2, which is 4 plus 2, which is 6. So we're going to select the positive box. And then the last one, A plus C is -2 plus 4, which is 2. And again, we'll select the positive box. So -0, negative, positive, positive. We good on that one? Go to number 2 and please remind, what does this one say? Expressions, thank you, because some of yours are out of order for whatever reason than the ones that I have. Okay, so yours is this one here?
Yeah.
Okay. This is also 5 questions, because we're going to have to simplify the first expression that they give us here, and then we have to see which of these are equivalent, which means we have to simplify all of them, which is why your ILEARN is not going to have 53 questions on it like NWEA, because of how jam-packed they are. They're not just testing you on whether or not you can simplify, they're testing you on whether or not you can operate, add, subtract, multiply with decimals. Okay? Without a calculator. So let's simplify the first expression they give us here. There are 2 ways that you can simplify expressions. Number 1, if you have parentheses, you got to get rid of them by distributing. So distribute. That's the first way you can simplify. You can distribute something. Now, I know you're thinking, if there's parentheses, shouldn't we do what's in parentheses first? I'd say yeah, except here. You can't do anything. These are not like terms. So you can't add them together. There's nothing we can do with those. So we'll distribute the number in front of the parentheses. The second way you can simplify is by combining like terms, which we should be very familiar with. We're going to do both those things. And after we're done, We'll have one constant term and one variable term. So let's start with the parentheses. What's the number directly outside the parentheses?
Positive 2.
+2, thank you. We're going to distribute that +2 to the numbers in parentheses. This is a non-calculator portion, although I doubt you need a calculator to do 2 times -4. What is 2 times -8? Okay, so -8x. And then you could use a calculator, could go off to the side to do 6.1 times 2, or you could just write 61 times 2. The issue with writing the decimal point is that when we multiply, a lot of you will try to line up the decimal point, but when you multiply, you don't need to. You only need to line up the decimal points when you add or subtract. So what I do is I don't even write the decimal point. I'll just do 61 times 2, which is 2 times 1, and then 2 times 6. And then because it had one decimal place in the problem, we'll have one decimal place in our answer. So this is just 12.2. And if you think about it, if you double 6.1, it makes perfect sense that you'd end up with 12.2. We're going to copy down the rest of it, copy down the -3.25x. Obviously, we already distributed the 2, so copy down the -3.75, and then that -8x becomes, or -8x becomes a -8x there. Now we can combine like terms. Let's do our variable terms first. -8x, -3.25x. -11.25. They have same signs or different signs? Same signs means keep the sign and add. So you're just adding the 8 and the 3 to get 11.25. And that was your x term. And if you want to go off to the side, you can. You'll just do 8.00 plus 3.25 to get 11.25.
Okay, so I have a question.
Sure.
So, and then the next part would be plus 12.2 minus 2.75. We should simplify that, right? They didn't
Well,
do that. They just
Well,
simplified
we are going to simplify it.
it. Well, like for one of the answers.
Well, not all the answers are right. We're going to select the ones that are right. Okay. So Cooper's right. We're going to simplify those. Do they have same signs or different signs? Different, which means subtract. So when I subtract, I go off to the side. I put the larger number on top because I cannot subtract with a larger number on bottom. So 12.2 is going to go on top. 3.75 is going to go on bottom. I do need to line up the decimal points when I'm subtracting. Before I subtract, can you tell me if my answer will be positive because I got more of those, or negative because I got more of those?
Positive.
It will be positive, so we can go ahead and put a plus sign down, but I am going to subtract because it's not going to be as positive. When I subtract, there's a lot of what that I need to do. Not carrying, that's if you add. Borrowing. Borrow from the 2 to make it a 1 and the 0 a 10. 10 minus 5 is 5. Borrow from the 2 to make it a 1 and make this an 11. 11 minus 7 is
4.
Yep, 4. Drop down the decimal point. Borrow from the 1 to make it a 0. And what's 11 minus 3? 8. And we said that was going to be positive 8.45. Now it is simplified into one variable term and one constant term. Now I have to simplify these remaining 4 to figure out which of them would give me that exact expression. So start with the first one. Fortunately, there's no parentheses here, so all we have to do is combine like terms. What's 7x and -2x? 5x plus 8.1, which is not -11.25x. So that one's out, it's garbage. The second one, we can combine the -8x and the -3.25x. What's that going to give us? It is going to give us a -11.25 because same signs means keep the sign and add. And that -11.25x combined with the positive 8.45 is exactly what we're looking for. So that one is good. If someone was going to make a mistake on this one, where do you think the mistake would be? Devin?
The decimal points.
The decimal points could be the mistake, having it in the wrong spot. If you do the adding and maybe putting the 8 underneath the 5, for example, that could be a mistake, Claire.
Probably just adding or subtracting wrong.
Okay, maybe not seeing that that's a negative and doing subtraction instead of same signs addition. That could be. What else?
Ending it too early, because you see a -1.25 and then you see a weird.
Or not checking them all.
Yeah, not checking.
Yes, and that's why it says select all in bold expressions that work. You have to check them all. That's good. Okay, number 3, or not number 3, the third option. This one's automatically garbage because I'm looking for a negative 11.25x and there's no x's to even combine to negative 7.25. So this one is out. This is garbage. The last one does have the negative 11.25x. I just have to make sure that 12.2 and negative 3.75 give me 8.45. And if I keep my side work, I can see that the 12.2 and the negative 3.75 does give me 8.45 because I've already done that work. And so this is the exact same thing. So for number 2, you should select options 2 and 4. Good. All right, next one. Is your next one the same as my next one?
Yeah.
Enter the value of C?
Yeah.
Okay.
Yes, that's right.
Now, I made this a couple of years ago, so they may have updated it. I don't know if your keypad looks different from the one they give me. Okay. Enter the value of C when the expression 21.2x plus C is equivalent to 5.3 parentheses 4x minus 2.6. So this is another one where they're going to have us simplify. And we have a number outside the parentheses that needs to be distributed to the numbers inside the parentheses. So I have to do 5.3 times 4. So I could just do 53 times 4. What's 4 times 3? Carry the 1. 4 times 5 plus the 1. And then instead of 212, because I had one decimal place in my problem, 5.3 times 4, I should have one decimal place in my answer, and that's going to give me 21.2x. If you're multiplying with decimals, it's easy to check to see if your answer could be right by just rounding that to 5 and doing 5 times 4 is 20. I know my answer should be close to 20, and 21.2 is not that far away. If I would have left it as 212, I would have known something was really wrong. And I just, in that case, forgot a decimal point. Now I have to do 53 times 26. And there's 2 decimal places that are going to be in this answer. What's 6 times 3?
18.
Carry the 1. 6 times 5. 30 plus the 1. Drop a 0 down. 2 times 3. 2 times 5. Add them. 8 and nothing makes 1 and 6 makes 3 and nothing. 1 and nothing. And 2 decimal places makes this minus 13.78. Now let's answer the question. Enter the value of C so that this expression is equivalent to this one. What would I have to add to the 21.2x in order to make it exactly the same as that one, Caleb?
13.7.
No.
Oh, double it.
Double it. No. Claire.
Negative 13.
Negative. Did you notice that we have a subtraction sign here, but they have an addition one? That's fine, as long, but I have to realize that if I just put 13.78, that adding 13.78 is not the same as subtracting it. So if I add a negative 13.78, then they would be the same. And so I got my negative button right there, negative 13.78. This is just like big ideas where I type my answer in. So we've seen so far a hotspot question. We've seen a select all that apply question. And this is now a type your answer in question. Let's go to number 4. Yeah, Devin?
Would this be one of the questions where somebody would personally grade it?
Nope. My guess is that they would have a computer grading this one. And if anyone who put 13.78 would get 1 out of 2 points or 2 out of 3 points, depending on how many points they make it worth. Okay, so they would have a group of partially correct answers. Yes, you have reached the end of this part of the test. This was the non-calculator portion of the test, which I'm sure we'll have more questions on it Monday when you take your non-calculator part. But for right now, I need you to go ahead and move on to number 4 by clicking the next arrow and then saying, yes, I know I can't go back. And as I mentioned, when you move on to the calculator questions, you are no longer allowed to go back and check any of the work or answers to your non-calculator questions. Now, at the top right of your screen, do you see the calculator icon?
Yeah.
Click on it. Type in something easy like 4 times 6. Okay, now, do you see, yeah, it shows up on the other side. Do you see that it already calculates it without you having to hit enter or equals?
You know, 4 times 8 times 8 times 9 times 2 was 34.
That's awesome.
Oh, you first answer.
Caleb,
If you type like a really big number, it gives you a number and then times to like 10.
yes, that's scientific notation. You'll learn about that in 2 chapters from now.
Yeah.
No, actually, next chapter. You might have. Number 4. We just got done talking about probability last week. If you were here on Tuesday and Thursday, you should be able to answer this question. If you were here on Tuesday last week, this is just simple probability. It has nothing to do with compound probability. You're not drawing 2 marbles out of the bag, just 1. A bag contains 16 marbles. There are 5 blue, 9 yellow, and 2 red marbles. 1 marble is selected at random. That's why this is simple probability. Just has 1 fraction. Determine whether the statement correctly describes the likelihood. Now, remember, we talked about likelihood on a spectrum of 0 to 1. What did we call a probability of 0? Done. Claire.
Impossible.
Impossible. What did we call a probability of 1? Devin? Certain. What about if it's 50%?
Unlikely.
As likely as not. Anything from 0 to 50% we said was unlikely. Anything from 50 to 100 we said was likely. So unless it's 0, 50%, or 100% / 1, it's going to be either unlikely or likely. So this first one says it is impossible, which means a probability of 0. It is impossible that a green marble will be selected. Would you say that's true or false? That is true. There are no green marbles in the bag. So my fraction would be 0 out of 16 marbles. And that reduces to 0. And that's why we're going to say this is impossible. The next one says it is unlikely that a yellow marble is drawn. Now, I need you to hear me say this. Just because there's more yellows than any other color does not mean that it's going to be likely or unlikely. I have to write the fraction down and see how that fits into the 50% mark, right? There could be more yellows, but it could still be unlikely. If I had 10 different colors and 2 of them happen to be yellow, sure, I'm more likely to get yellow than something else, but it's still unlikely to happen if I've got 8 of the marbles. So I have to write the fraction down. There are 9 yellows out of 16. Would you say that's more than halfway or less? Yes, because halfway, 50% would be 8 out of 16. And so this is going to be likely. And so they say it is unlikely. We say false. It should be likely. It is certain that a blue marble will be selected. False. If the bag only contained blue marbles, I would agree, but there's other colors. As soon as they throw one other color in there, you can no longer be certain. It is unlikely that a red marble gets drawn. That's 2 out of 16. Would you say that's unlikely?
Yeah.
I would as well. That is true.
Very unlikely.
Is it this your number 5?
Yeah.
Okay. Figure A is a scale image of figure B. This should be easy for you guys because scale images or scale factors are proportional. So what we have here is 2 triangles that are similar. And you're supposed to find the missing length of the larger triangle by using the scale they have below. The scale that maps figure A onto figure B is 1 and 7 1/4. Now, since you have taken 8th grade math, can you tell me what we call a transformation in which the image is a different size but the same shape? Levi? It is proportional, but what do we call that transformation that's proportional? Cooper? A dilation. Yes, this is a dilation. And so what we have here is that for every 1 unit on the small triangle, it's 7 1/4 units on the large triangle. What should we call 7 1/4 as a decimal? Okay, so here's my first ratio. For every 1 unit on the small triangle, it's 7.25 units on the larger triangle. That's just taking this ratio and instead of writing it with a colon, writing it as a fraction. Then we can say, if that's true, then 3, which should be put on top or bottom, top with the other small number, because it came from the small triangle, would be proportional to this x value that we have for the same side, corresponding side on the larger triangle. We cross multiply. 1 times x is just x. 7.25 times 3. Jocelyn, what is that? 7.25 times 3. 21.75. That is your answer. And this one is also just a type your answer in. Now, I don't know if your box looks like mine. It does? Okay. They give you a bunch of stuff you don't need. I don't need to use any of this stuff over here. I can just type in 21.75.
Do we ever have to use a parcel?
Possibly. If it says write your answer in terms of pi, which actually, even in 7th grade math, they learn to do that. New check.
I wouldn't type it, type your answer like long, so this is later. Like, sometimes I can beat this as a calculator.
Yes, it is not a calculator. So it is the answer box. Now, if you don't type anything in, it won't let you move on. So if you had this typed in your calculator and you're like, oh, that's my answer, and you try to click the next arrow, it'll say you cannot move on until you type an answer in. Okay. Now remember, if you don't know how to do one like this, you can mark the flag. If you click on the little hamburger menu there, and then mark it for review, it'll flag it, and then you have to put something down to move on, but it will highlight it when you get to the end of the test. Remember when you guys got to that first section, it said 1, 2, and 3?
Yep.
Well, you could jump back to 1, 2, and 3 if you want to review it. If you mark it for review, it'll put a flag or highlight that question so you know that you need to go back and look at it. All right, number 6. The graph shows a proportional relationship between the number of hours a factory is in operation and the number of gallons of water used. We talked about proportional relationships during our slope-intercept chapter. What is another name for a proportional relationship when you're looking at a graph like this? No, it doesn't start with an S.
What does it start with?
A D. No.
Direct variation.
Yes,
Direct
nice
variation.
job. It's a direct variation. That's what the 7th grade calls it. You could call it a proportional relationship. Actually, it should have been flip-flop. They should have had them call it a proportional relationship, and you guys call it a direct variation. Because the direct variation formula is y equals kx or mx, and there's no b value, which means the b value is 0. And if the b is 0, your line has to go through what point? The origin. Every proportional relationship is a line going through the origin. If it doesn't go through the origin, it is not proportional. This one is, which means every single point on the line, if I divide, should give me the same as every other point. For example, the factory uses 10,000 gallons of water in 10 hours. What's 10,000 divided by 10?
Oh.
1,000.
1,000. What about this? 8,000 gallons was used in 8 minutes. What's 8,000 divided by 8? 1,000. What's 4,000 divided by 4?
1,000.
I get the same value. Now, the interesting thing is that value that I keep getting doesn't just prove that it's proportional, but that value that we keep getting is the unit rate. To find the unit rate, you would see how many gallons per hour you're using by dividing any one of those points. Now, the only point you can't use is the origin because you can't divide by 0. But if I do 2,000 divided by 1, I'll get 2, or I'll get, sorry, let me go over to the line. If I do 2,000 divided by 2, I'll get 1,000, or 4,000 divided by 4, or so on and so forth. If you want to know what your unit rate is, you can always just look at the number 1 and see what the Y value is. 1,000 gallons per hour. Now we're going to answer, this is also true, false. The factory uses 4 gallons of water when it is in operation for 4,000 hours. True or false?
False.
Why?
Because it's flip-flop.
Flip-flops. They got their labels wrong. It uses 4,000 gallons for 4 hours, not 4 gallons for 4,000 hours. That would be great. Point W. Point W represents the gallons of water used when the factory is in operation for 7 hours. True or false? Yes, that point shows you that for 7 hours, I can get that to go right down the line, it uses 7,000 gallons of water. So that is true. And third one, the factory uses 9,000 gallons of water when it's in operation for 9 hours. Also true. That's still 1,000 gallons per hour. So it should be false, true, true. That's right. That's how much water they're using.
That's a lot of water.
Now, a lot of factories are near rivers. And so they'll pull river water in and not like filtered water or anything that people could actually be drinking. They'll use river water and use that water, and then their leftovers go back into the river. Hopefully not polluted leftovers, but there would be some sort of, usually like this, they use the water to cool something down and then it turns into steam. So when you like, if you've been around Cincinnati, for example, and if you look around the Ohio River goes through Cincinnati, like right through it. Like on one side you got Cincinnati, Ohio, on the other side you have Covington, Kentucky. And so if you look, a lot of the factories, it looks like they're just polluting toxins into the air. A lot of that is just steam. Okay, I'm not gonna vouch for all factories, but a lot of that is steam, and they use that steam has to go somewhere. So they pull that river water in to cool down the metal or whatever they're working with, and that steam has to go somewhere. So a lot of that what you're looking at is steam. That's why it eventually goes away. You can't see it anymore because it just finally evaporates. Yes.
Or if there is polluted water, then you'll go to a place where they clean water. Go back.
Yeah, hopefully a recycled water plant. Mhm.
Wait, so could you jump in that without dying?
The river?
Yeah.
I wouldn't drink any of the water though. Number 7 is an inequality. And we worked with inequalities this year. In fact, we worked with multi-step inequalities. This is just a 2-step inequality. Devin, what's your question?
Oh, I was gonna say I do it.
Okay, well, let's write it down on our paper first. 6x minus 4 is less than 8. And Devin, tell me the first step in solving this inequality.
You have to add 4 to both sides.
That's correct. Remember, your goal when you solve an equation, and an inequality is a lot like an equation. Your goal is to get x by itself. And to do that, you have to get the x term by itself. And to do that, you have to get rid of any constants that are on the same side. So we put a +4 because that's going to eliminate the -4. And Devin, what's 8 plus 4? So now we have 6x is less than 12. Okay. Levi, Shoemaker, take it from there.
Divided by 6 on both sides.
Okay. Now, before we write our answer down, sometimes when you work with inequalities, you're forced to flip the inequality symbol.
That's ridiculous.
Yeah, for negative.
That's for negatives. Anytime you are multiplying or dividing your inequality by a negative number, you have to flip the sign. If this would have been a -6, I would have had to divide by -6, which would have forced me to flip the sign. However, I am not going to flip the sign here. So Levi, what will my answer be?
The open source or OBS is less than
2. Okay, now you said open circle. What do you mean by that? You don't know. You just said those words because they popped into your
well,
mouth.
I know like how to decide whether it's open source.
Okay, tell me.
If there's if it's equal to or if it's less than or equal to, it's a closed circle. It's just equal to.
Okay, good. Okay. So when you are graphing an inequality, you are shading in all the possible values for x. If it says x is less than 2, you want to shade in all the numbers that are less than 2. So what side of the number line should we be shading? The left side, everything left of 2. But like Levi is saying, sometimes we have to shade in the 2. This is not one of those times. It says x is less than 2. So we do not want to shade in the 2. So the arrow that you select cannot have what we call a closed circle. Because if you close in that circle, that means 2 is a possible answer because you also shaded it. You have to leave the circle open. And the way you can tell is if there's an equal bar underneath your sign. If there's an equal bar right there, closed circle. 2 is a good answer. There's no equal bar. 2 cannot be a possible answer. So you're clicking on the arrow pointing to the left with an open circle, which is this one here. You're going to drag that arrow to where that open circle is right on the 2, showing that we're going to shade everything to the left. Those are all possible answers for x. That might be the hardest question on this test. I'll give you a moment to do that because dragging it isn't so easy.
You have to tap it, then drag it.
Tap it and drag it.
No, I just drive it. You don't have to tap it.
You wouldn't let me tap it. You have to add it.
While you're doing that, just another reminder, if you end up multiplying or dividing by a negative, which I doubt that you'll have to do on the ILEARN, but if this was a negative here, you would have to divide by a negative and then flip the sign. What if this number is negative? Nope, doesn't matter. That number doesn't determine what I'm dividing by. Only this number does. So if this number is negative, nothing changes. Other than I'll get a negative answer, but it won't flip the sign. If this number is negative, I'll get a negative answer and have to flip the sign. Cooper.
Why is there like the grammar on the side right here?
That's a refresh. All right, next one, number 8, a company makes 2 sizes of boxes shaped like rectangular prisms. The large box is 16 inches tall, 10 inches wide, 10 inches long. The drawing shows the dimensions of the small box. Take a moment and process what we just read. They said 2 boxes, but only gave us a picture for 1. Which one is this a picture of? Okay, so this is the small box. Not small pox. Okay, let's write down the dimensions of the large box then. Someone give me the dimensions of the large box.
16 inches small, 10 wide, and 10 wide.
So 16 by 10 by 10. Okay, let's look at part A. What is the maximum number of small boxes that can fit inside the large box? If we're talking about the space inside a 3-dimensional shape, what are we referring to? Volume. How do you find the volume of a rectangular prism? Anybody? Length times width times height, specifically for rectangular prisms, you're right. So for the small box, I would be doing 4 times 2 times 2, which is
16.
okay, and we would measure that in cubic inches, although ILEARN test isn't going to have you label your answer. For the large box, 16 times 10 times 10,
16,000.
I mean, like 16,000.
1,600. 1,600 is how you would say if you're trying to say what
Yeah,
Cooper's saying.
16 times that.
Yeah.
Oh, 16 times that.
Part A. What is the maximum number of small boxes that can fit inside? Devin, explain.
100 because 16 times 100 equals 1600.
You're exactly right. Take the volume of the large box, divide by the volume of the small box. 16 goes into 1,600 100 times. Anytime I want to know how many times a number goes into another one, I'm dividing. And I'm trying to figure out how many small boxes go into the large box. So I divide. And so the answer to part A is 100 small boxes. Part B. The company plans to increase the width and length of the large box by 4 inches each to create a new larger box. How many more of the small boxes will be able to fit inside the new larger box? So now we have a new larger box. They're increasing the length and the width by 4. So we have the height of 16 for the large box, the length and width are 10. If you increase those by 4, what's our new length and our new width? Okay. So Nuche, tell me what 16 times 14 times 14 is.
That would be 3,146.
Okay. That's our new larger box volume. And I want to know how many more of these small boxes will fit inside. So I divide and find how many will fit inside. 196.
Might as well just square 14.
You're right. 196 is a perfect square. Now, 196 is not the answer to part B. What is the answer, Levi? Just 96. So that's why we have to be good readers of the instructions. It says how many more boxes. 196 is what 3136 divided by 16 is, but I'm trying to figure out how many more boxes will go in. So subtract 100 that were already going in, and you can fit 96 more boxes in. Devin,
Do you think you give partial credit to put or not?
I'm positive you get some partial credit for that. All right, the number 9 should be this one here. Now, we didn't talk about this question. We left off right in our probability questions where we were getting ready to talk about samples. There are 2 types of samples, biased samples and unbiased samples. If you have a biased sample, that is bad. Okay, think biased. What does biased mean to you? Cooper?
It means you have an opinion about something before you do the.
Yeah, that's actually the definition of it. In math, that means you're favoring one part of the sample over another part. You've already made up your mind. It would be like me doing a baby talent show with my own baby in the talent show and being a judge, right? That wouldn't be fair. Even if I try not to be, I'm probably going to be biased towards my own. Okay. Or like playing a baseball team and your friend on the other team, his dad's the umpire. Okay. You would think, oh, that doesn't quite seem right. Okay. That would be biased. Now, when you're talking about samples, there's really three ways to make sure that you get an unbiased sample. We want unbiased samples. Number one, make sure everybody had a chance to be selected. If I say I'm going to do a survey of our middle school to see how many people would prefer to do a school uniform like this one, or just wear regular clothes, and I said, all right, I'm going to go ask Mrs. Lazar's first period class what they think. That wouldn't be representative of our whole school. That would be biased. So that number one, make sure everybody had a chance to be selected. Number two, not everybody can be selected. There's too many people. So make sure you do it randomly. Random samples are always good. Okay. Number three, if I go in and say, I'm going to ask these 6 people what they think, it's going to be hard for those 6 people to think, to make my decision off of the whole school based off 6 people. So make sure it's large enough. Make sure everybody had a chance to be included. Make sure it was random, and make sure it's large enough. Now let's look at the options here. The principal wants to know how many students favor the new dress code. So she's not able to ask everybody, obviously. She's going to do a sample. Which of these is representative or is the best sample the principal should choose? A, students randomly selected from a list of students at the school. That sounds good. Let's keep going to see if we find anything better. Students sitting at randomly selected tables in the library. They did it randomly.
But
What's
it's
wrong?
biased against the library.
It's biased. If you're not in the library, you didn't have a chance to be selected. Where we could say everybody's on a list of all the student names at the school. Also, probably not large enough. Probably not that many people sitting at tables in the library. So this one's out. Students selected from the hallways between classes. No, you can't get to all the hallways. So you're only going to be picking students that you were in that hallway of. That's biased. You're not including everybody there. Okay? This is one like Camden said, where you probably don't even have to use it.
I mean, you don't know, maybe.
And then D, students selected by the teachers.
No.
Not random. Teachers are choosing, not the principal. And she want to make sure you do it random. So the answer choice was A.
Well, if you're saying it's biased because teachers.
You guys want to do this the whole period?
No.
Okay, then stop making the noises. Random's good. It's also going to be large enough too, I assume, if you're picking from a list of everybody. And because the list contains everybody, everybody had a chance to be chosen, even if they weren't, they had a chance to. Versus people just in the library doesn't make much sense for that. Okay, your last question we're going to look at number 10 is the bicycle question. You might remember this question from the practice test and being very confusing. I'm going to show you a much easier way to do it, and then I'll read to you the way that they answered it, and we can compare and see which one makes the most sense. This is what makes sense to me. Emily leaves her house at exactly 8:25 a.m. to bike to her school, which is 3.42 miles away. When she passes the post office, which is 3/4 of a mile from her house, she looks at her watch and sees that it's 30 seconds past 8:29 a.m. or 8:29:30. If Emily's school starts at 8:50 a.m., can Emily make it to school on time without increasing her rate of speed? Show and or explain the work necessary to support your answer. The box that you're going to be using for this question is much larger than the box that we had for the other ones because they're having you show your work as well. So when it says show, okay, use these math symbols up here or anything on your keyboard, you can use as a math symbol as well to show your work. When it says explain, that means you can also write sentences to explain what you're doing. We're going to do both. Okay, we're going to do both. But before you start writing stuff down, solve the problem on your scrap paper first. So you don't end up having to erase and rewrite and erase and rewrite. We want to solve it first. So here's how I would solve this. Because we're trying to see if she can make it on time without increasing her rate of speed, we're assuming she's biking at the same speed the whole way there. If she's biking at the same speed the whole way there, that's a lot like our factory question with the water. There's 0 miles from home. If she bikes the same speed, this is what we're looking at. If she starts to slow down, what's going to happen to the line? It's going to take a dip. If she starts to speed up, okay, we're assuming that she keeps the same rate. And if she keeps the same rate, it's going to stay as a line through the origin, and everything on that line will be proportional. So we can use a proportion to solve. Here we have 3 different times. The time she leaves the house, the time she passes the post office, and the time school starts. We have 2 different distances. Her distance from the post office, house to post office, and from house to school. we're going to use all these numbers as part of this problem. And let's set up our proportion. We don't actually have, you probably remember this from science class, distance, time and speed or something like that, triangle like this. Yeah, we don't actually have to find out what her speed is. We just have to assume that it stays constant. So this is the proportion we can write. How far will she have ridden if she bikes from school, sorry, not school, from home to the post office? 3/4 of a mile. And since they're writing those as decimals, what would we write for 3/4 of a mile? Okay, so she bikes 0.75 miles from her house to the post office. That's the top part of our ratio. How many minutes does it take her to do that? 4.5 is correct. And what do I write if I want to turn 4.5 into a decimal? 4.5. We have to realize that 30 seconds is half a minute. You are not typing anything right now. You would be writing this on your scrap paper, getting your answer, and then deciding, okay, what's the easiest way for me to type what I did? Okay. I know. Okay. So if I divide those two numbers, that'll tell me the speed in miles per minute. That's actually not helpful for this problem, at least the way I'm going to do it. We're just going to assume that stays constant. So if she travels this far and it takes her that long, then at that same speed, she can travel from home to school, which is how far? 3.42 miles. In how long? We don't have an answer for that, so we put X right there. We want to know how many minutes it'll take her at that speed to get to school. Again, I'm not concerned what the actual speed is. I'm concerned with how long it'll take her to get there. So we cross multiply. 0.75 times X and 4.5 times 3.42. So 0.75X. George, what's 4.5 times 3.42? Okay. And then George, go ahead and divide that by 0.75. We'll have X by itself. All right. Elise, what did X actually stand for? X was the number of time. Yeah, in minutes, right? Okay, so here's what, let's take a step back and just figure out what we did because it was important. We just figured out that if she traveled from the home to the post office, took her that far and that long, then at that same rate, she could travel that 3.42 miles to school in 20.5 minutes, just over 20 and a half. What time did she leave home? What time is she going to get to school? Is she going to make it on time?
Yeah.
We just found out she's going to make it on time at 8:45 and 31 seconds. Right?
She has to get to her locker.
But it didn't ask that. It said, will she get to school on time? It never once said, will she make it to the first period class? Okay, I don't want to think that far into it. Okay, so I need to answer the question and show my work all in the same time. So this is what I would write. I want you guys to type this in just to show you how much you should be typing on these types of questions. The first thing I'm going to do is I'm going to tell them what I got when I converted 3/4 of a mile to decimal and 4 minutes and 30 seconds to decimal. So I'll say Emily travels 0.75 miles in 4.5 minutes. That was turning 4 minutes and 30 seconds because she got there at 8:29:30. 4.5 minutes. Oh, sorry. To pass the post office. Okay, to pass the post office. Period. We can use a proportion to tell how long it takes her to get to school. And then I'm actually going to write that proportion down. So I'm telling them what I'm about to give them. I'm giving them a proportion. We can use a proportion to tell how long. And since I can't write like exactly what I put on my paper, I'm going to use the slash bars on my keyboard to represent the ratio bars. So here's our proportion, 0.75 slash 4.5.
Wouldn't you do a little asterisk for the time?
Hold on, I'm going to put equals, and then the other ratio is 3.42 slash x. I'm just writing exactly what I had in my work paper, except I'm not going to put the labels. You can put them if you wanted to. Then I can either on the next line or I can keep going. I cross multiplied, and when I cross multiplied, I got 0.75x equals, what was it, 15.39? Okay. And then again, I could leave another, I could, on the next line, I could put x equals, or I could just keep going. X equaled 20.52. So that was me showing my work. This was me explaining what I was about ready to give them, so it didn't look like gibberish to them. Okay, that's actually a proportion, and I told them it was going to be a proportion. So that whoever's grading this says, oh, that's what that is. Not that they're probably not already looking for proportion anyways. Okay. Now I need to answer the question. This means she will arrive at school. Is arrive have 1 hour or 2 hours? I think it's 1 hour.
One has two.
Does it really?
Yes.
Okay. She will arrive at school at what time? At 8:45.
And 34.
At we'll say around 8:45. Or you could even say 8:45:30 like they did on the watch, right? It's probably 31, but whatever. Okay, so their question was, will she make it on school? Will she make it to school on time without having to increase her speed? The answer is yes. So let's say, so she will not need to increase her speed to make it to school on time. Or you could say she could make it to school on time without having to increase her speed. You could say a couple different ways there. You could say a lot of this, you could say in a different way, right? But that's about how much you should be writing. Explaining what you were about ready to give them and then telling, kind of answering the question there. Make it as easy as possible for the person who's hand grading this to see that you knew your stuff. Okay? Yes.
Okay, if she's at like 8:25 and she's already like 3/4 miles away from her house, and it's like, and it took her like 5 minutes to go that far. Why did it take her another 15 minutes to like 4 miles?
Well, she has to go a total of 3.42 miles to school.
Okay.
So when you take away the 0.75 miles she's already gone, she still has to go about 2.75 miles to get to school.
Okay.
Okay, so she's, I don't know, like 1/5 of the way there about.
I thought 3.2 miles was like a total. of how many miles?
That's from home. So what we did is we took the distance from home to the post office in that time, and then put the distance from home to the school and took that time. So if we knew the whole ride was going to take her 20 minutes, we can figure out, oh, that's enough time. She'll get there at 8:45.
Is that pretty?
Okay. Well, you can divide that and figure out how many miles per minute that is. Alright. This is what they had as their answer. This is what Mrs. Yentes would have read to you when you guys were typing this in. I'm sure she didn't make you write the whole thing. This is their answer. And you see if you can follow along with this. Emily can travel 3/4 miles in under 5 minutes. So she can travel 3 miles, which is 4 times as far, in under 20 minutes, which is 4 times as long. This means Emily will have traveled 3 miles before 8:45, which is 20 minutes after she left. Then there is only 0.42 miles to go. Since 0.42 miles is less than 3/4 miles, we know she can cover that distance in less than 5 minutes. This means she will get to school before 8:50 and she'll be on time.
How's the lot?
It was a lot, and they kind of focused on the fact that they broke it into how far has she already gone and how far does she still have to go. And we don't have to do that, actually. Setting up a proportion, we don't care how far she still has to go. We can use that distance and time we were given to the post office to predict when she will arrive at school. And that's all we needed to know. It's going to take her 20.5 minutes to get there, and that puts her there before 8:50. I think it's easier to do with a proportion.
It definitely is, like, their words seems a lot, like.
I think the idea is you could answer this a lot of different ways, though. Just make sure that you're explaining it very well, and this is untimed, so take your time in doing it. Okay? Now, make sure you click out of this box by clicking on this picture and then clicking the next arrow. If you don't click on the picture and it still thinks you're in the box, it will not let you move on. Then you can end the test. Okay? This was not for a grade. You didn't even log in with a test ticket number, so don't feel like, oh, I might have gotten something wrong. This is complete practice. Okay, so then you can log out, and when you submit the test and log out, it will unlock your iPad screen. Now, you guys can use this Test Secure app going to the repository site. Oops. And you can check out any of the questions you want to. So if you wanted to look at, like, I don't know, what are the 6th grade questions that you would have taken last year? If you want to see what they would have looked like. If you want to look at what the 8th grade questions look like, which we'll look a little bit at those, you could actually do that. Okay. Every question that you will find here is on the ILEARN website. You don't even need an iPad with a Test Secure app. You could just Google ILEARN practice questions, and it will take you to their page where they have all these listed. I wanted you to do it on the Test Secure app because I wanted you to get familiar taking it and typing it on your keyboard, which is what you'll have to do starting tomorrow.
But your iPad gets locked.
Of course, tomorrow you'll be taking just the language arts computer adaptive, not the math. Okay. Any questions?
If you were to do it, you gotta
Okay.
remember that your iPad is
There-
locked.
You're right. Yeah. So you can't go into another app.
Yeah.
It unlocks after 8 hours.
Good to know.
8 hours.
You know that.
So
It tells
anyone that has not turned in the Algebra 1 G.4 IXL, you need to make sure that gets turned in by 2:30 or it's late. Okay. No, I just need you to make sure you get to 90. Okay, I'm going to be checking scores after school.
Once you get to 100, you get one.
Caitlin Sylvester, I need you to do your perfect squares. And Camden Rob, I'm going to give you one opportunity if you want to. You're currently at a 24 out of 25.
Yeah, I forgot.
Okay. Why don't you take, yeah, you guys use the restroom. I don't know if there's enough time, Camden, but I'll give you this.
Oh,
And
yeah.
we can finish it tomorrow. Don't go home with it, Camden, but work on it until it gets time to leave. No. Nope, I do not.
So the ISO, can I do that tonight?
You get an extra day on that.
Okay.
Yep, so it'll be due for you tomorrow then, okay? And it's just over distance formula and simplifying square roots. So for example, if you get square root of 80, 80 is not a perfect square, but you can pull out a perfect square from it. 4 goes into 80, it'd be square root to 40. And then you could pull out another 4, because 4 goes into 40, and then you could keep simplifying it, okay? So we had a whole lesson on that. You can look in the notes from the Pythagorean theorem part 2, and it shows you how to simplify square roots, okay? Now, are you ready for your perfect squares?
I'm gonna use the restroom.
Okay. Oh, I need to stop recording.
I fell asleep.